So, now we are ready to go with our last, but certainly not least, talk of the day. Everyone, give your loudest, cheeriest welcome ever to Mo from Theodo! Woo!
Thank you very much. Can you all hear me? Amazing. So before I came on stage, someone from the crew pointed out two things to me that I want to share with you. Firstly, I'm the last person speaking, so apparently I have a very difficult job ahead of me. And secondly is that if I put one of the other mics on, apparently my beard would make a lot of noise and you guys would all be going deaf, so I'm going to have to hold this, so we'll see how this goes. Lovely to be in Berlin. Thank you, everyone, for everything. Big shout out to Sanket, his team, the crew, the volunteers. Give them a round of applause for everything they've organized. It's their first year. By the way, random thing, did you know this building used to be a church? It's really cool. It's my first time giving a talk at a church, so I feel like I should be giving like a sermon or something, not a talk about front-end development. But hey-ho. It's the last talk of the day. I'm going to say some stupid shit, so buckle in. It's the only way I can keep you guys awake. Awesome. So we're going to talk about how front-end is going to change in the next 5 to 10 years. And hopefully things will go well. Several times during the day today, we heard about write once, run anywhere. You've already heard this a couple times. It's the ultimate goal of front-end developers and UI engineers. Could we develop an app from a single code base that could run on any platform that we wanted to? And it turns out it's nothing new. If we go back to the late 1990s, and you come home after a long day of work, and you sit down on the couch, turn on your TV, you might see an ad like this playing.
Who would have predicted that Java could change the way we view the world and the way we live? It entertains, it communicates, it transacts, it speeds across the ground, soars through the air, seeks out new frontiers. Anywhere and everywhere, Java is there.
And just like that, write once, run anywhere, and Java everywhere became the mantra of Java. Suddenly you could use Java as this magical technology to target web, phones, and your desktop devices. Great, right? Definitely how that stayed. Fast forward a decade into the late 2000s, and it's the age of Flash. Great time, right? Raise of hands, is there anyone here who hasn't experienced the web in the age of Flash? You lucky buggers. Honestly. And so congratulations to you, Anisha, and to the other person who raised their hand, and to the rest of all of us, condolences, because it was a shit time. So late 2000s, early 2010s, Flash was everywhere. It worked on Windows, Mac, Linux, and the web, and then all of these other platforms as well. They were supporting the mobile platforms of that age. Android, BlackBerry, Palm, Windows Phone, Symbian. Great time. And they were trying to take this write once, run anywhere approach and move it to more and more platforms. They were targeting PlayStations, the Wii, Xbox, so on and so forth. So you saw that they were going through this expansion. And they had a whole ecosystem of partners around them. They really felt like the contender that was going to solve write once, run anywhere. Now, both of these technologies at their respective times were actually at the forefront of app development. They promised to let developers write once and run anywhere. But they ultimately ended up failing, and write once, run anywhere became a joke of the dev community, and it changed to write once and debug everywhere. Not a great look. And both of these technologies declined over time. So if you look at Google Trends and compare Java and Flash, you'll see from 2011 to 2024, they've both declined relatively, and Java is including Kotlin within that umbrella term. So this is taking into account that a lot of people in the Android development or in other places have moved from Java to Kotlin, and with that in mind, it's still declined significantly. And then sometime in 2015-ish, some new technology came into fruition, and suddenly it's been climbing up the ranks. And it's promising something very similar. Write once and run anywhere? So is this one going to be true? Is this one going to work out? Or are we just chasing the same pipe dream as our predecessors? My name is Mo. That was the longest introduction I've ever done to a talk. So I work at Theodo. I work very closely with Charlotte, who just did a talk a couple slots before me. I head the mobile team in the UK, and what that means is I do a lot of research into what the next trends are in mobile development, app development in general. I organize the React Native London meetup, which is probably one of the funnest things I do in my job, and I also maintain the React Native TV blog. That's like a knowledge base of React Native TV information. And so a lot of what I do with mobile has to do with universal apps, and recently I was giving a talk at a meetup, and I mentioned write once, run anywhere. And in the QA section, an older gentleman who definitely has a much longer career than I have looked at me and basically asked this question. He said, I've been hearing the promise of write once, run anywhere since the 90s. It was the promise of Java and Flash, and they both failed. Didn't work. So, young engineer who's giving a talk today, what makes you think React Native will succeed? In a very patronizing tone, he said that to me. But his question was very valid. And it links back to the architecture of how we're trying to target cross-platform applications. So if we look at Java, the way that a Java front-end application would typically work is you would have Java source code that goes through a compiler. That compiler compiles out to bytecode that needs to be run on the JVM. So you have a custom runtime that sits on top of the OS that's interpreting and running your bytecode. And so your bytecode is not being run by the operating system, but it's actually being run by the JVM. So there's that level of abstraction, and it means that it's not actually truly running natively. Similarly, we have Flash. So Flash was ActionScript source code. It goes through a compiler, and then it comes out as a file that needs to be run in the Flash runtime. It's, again, a custom runtime. It's not native, so it means that you can tell that it's not running on the native device. And if it needs to interact with the OS, it'll connect. But by and large, your app is running in this custom runtime. The best comparison I can draw is that it's kind of like a really good Bob Ross painting. Like if you just like stare at it straight from like a direct angle, maybe what you'll see is it'll look like a real picture that someone's taken. But the moment that you kind of step a little bit and look at it from a different angle, you're like, ah, that is a fake canvas. No dig here at any other cross-platform technologies. So it looks a lot like the real thing. It looks a lot like native applications, but it's not really native. So that leaves the question, what about React Native? And React Native is a bit different. It's subtle, but that difference makes a difference. And the way that it works is you've got React code. It goes through a bundler and a build process. And basically, that build process is the native build process for each of these operating systems. So your native app is truly native code that's being added with a layer of JavaScript that orchestrates some of the native functionality under the hood. It's a very gross oversimplification, but bear with me here. And then for iOS and Android, it has individual native app bundles that run. So what that really means is that when you have a view in React Native, under the hood in Android, it becomes an Android.view, which is the native view component. And on iOS, it becomes a UI view. It's a common API that uses native components under the hood for each of these platforms. And the best quote that I could say for this is React Native is native. And that's by Taz, a good friend of mine. I need to stress this again. It's a common API with native components. So when you've got an app like this is straight from the docs. The views are Swift views, or sorry, Objective-C views. Image views are the same, and so on and so forth. All of these components will be native layer components. They're not some web view, which is surprising how many times people think that they're web views. So it's a subtle distinction, but it's incredibly important. And the key to success is the right abstraction when it comes to building these solutions. Now, as we saw with Java and Flash, these technologies come in waves, right? Nothing is permanent. And these waves only last for a certain period of time. So I think it's a good time for us to take a look at some of the eras of front-end from 1995 all the way up to 2025. So going a little bit into the future. If we draw out our nifty timeline, From 1995 to 2005, we had the desktop first era. So this was the time when Windows was predominant as an OS. Nobody really used Mac OS back then. It was very rare. If you wanted to write a document, you would need to buy a copy of Word, take a CD, put it into your computer, install Word, install PowerPoint, install Excel, and the icons looked all glossy like that back in the Vista days. If you wanted to shoot messages to your friends, you'd have to use Yahoo Messenger. Did anyone here use Yahoo Messenger, of course? Yes. It was a good time, wasn't it? And then you needed to have these clients for emails that were running on the desktop as desktop client applications. Some point between 2005 and 2015, Chrome really popped off and everyone started adopting Chrome, and the web just became more and more powerful. And we transitioned to the web first era, where suddenly a lot of the things that you would need client applications for, you could just do with the power of the web. And so you could use Google Drive instead of having to download a client app. It was just all web-based. Facebook came in, so you had a web platform for social interactions with your friends, and you could poke them. Jeez. And then you didn't need mail clients anymore. You just had Gmail on the web, and you could just use that. And then we transitioned more recently into the mobile first era. So this was the era of the app stores. It's when WhatsApp, using messengers as your default form of communication, became normal. Side note, I really like making phone calls. Like, I just pick up the phone, call people randomly, and I'm weird like that. Like, phone is great. You don't need WhatsApp. You always have connection. There's no internet issues. Usually it's quite reliable. And without fail, when I call someone these days, they hang up the phone and then they WhatsApp me saying, "Why are you calling me?" Like, I'm trying to speak to you? I think we've just all associated collectively phone calls with our great aunts who we've been ignoring for 6 months and don't want to pick up their phone call. I don't know, like, there's something there. We've changed, our wiring has changed in the mobile first era. Streaming music became a thing instead of owning music. You know, social networks like Instagram popped up. You've got, you know, news on your phone. There's an app for it. Ordering a taxi is an app now. Like 20 years ago, if you told someone, they'd look at you and think you're crazy or something, but this is the reality we're living in. So this has been the case for the last 10-ish years that we've been in this mobile first phase. But I think it's time to address the elephant in the room, which is that the mobile first era is over, empirically. And I realize this is probably a very unpopular thing to say to a group of React Native developers, like, risky. But hear me out here. Technologies typically follow this S-curve. So they start off really strong and they have this exponential growth, and then they tread off and slow down. And you can see this with mobile phones and smartphone usage in general quite significantly. If you look at a graph of global smartphone users, that is pretty much like for like an S-curve. This is something I really like. So in the last 30 years, it shows the increase in the population, the adult population around the world, PC users and mobile users. So take a look at that. You know, slow growth in the 80s and the 90s, PC usage is going up, and then some point in the late 90s, you get a lot of mobile users. But in 2007, 2008, it just exponentially explodes, and suddenly everyone has a mobile phone. The vast majority of the public have now got smartphones. It's been adopted. It's a technology that's mature now. And one more graph to prove it to y'all. If you see here, 4 different technologies. One in the 20s was radio. It reached 100% of the population had access to radio by the 40s and the 50s. Same thing with TV, just a much faster growth. Internet was the same, but happening in the 90s. And mobile, this has been happening recently, and you can pretty much see it's starting to reach that asymptote as well. And also the same thing when you look at engineering jobs. Mobile demand has, oh God. This is what I get for saying this stuff at a mobile conference. Cool. Mobile jobs have just declined. This is the first 4 months compared to 2023. So the mobile first era is just categorically over. Maybe it's the age of AI and agents? I sure as hell hope not, because that's not going to be fun. Is it perhaps the end of front-end? No, that doesn't seem right. Not quite. You see, there is light at the end of the tunnel, and I genuinely saw some people leaving this crowd, so I have lost people that like me now. Great. I think we're just evolving. So what we need to be asking is, what is this next era of front-end going to look like? And the best way to answer this question is to understand how the best applications that we have out there that we interact with are influencing and changing and adding new behaviors and functionalities that users start to seem to expect. So I'm going to kind of tell this with a story. So when I wake up in the morning, I usually spend quite an obscene amount of time scrolling in bed. And it's not on TikTok or Instagram or anything like that, as you might expect. I'm incredibly boring. I scroll through my emails in bed. It's really quite sad. And then one of the things that we see on the OS level is when you want to use that or pick up that session and use it on your Mac, there's automatically an icon there to hand off that experience. So the session, the state, everything is passed to your desktop automatically, and you don't even have to think about it. So you click that and you open up the email on your mail client on your laptop with minimal effort. It's all automated now. It's not just on the OS level, this happens on applications as well. So if you look at something like Google Maps, if you search for a location on the web, and then you get into your car and you want to go to that same location, it's already pre-filled for you. This is very subtle, right? You might think, oh, this is not a big deal. But actually, when you don't have this in your app, your users notice it because their whole experience across all these other apps has been straightforward without needing to think about syncing between their different devices. And then if yours doesn't do it, suddenly they're like, wait, I need to send this location via WhatsApp and then open it up, copy it, and put it inside of this app from the desktop. It's too much. People just expect this by default. It's now the status quo. And it's not just between desktop or web and mobile. You see it with all of these different devices around you. So if you've got a talk that you're watching on your commute back home and you get into your living room, you don't want to watch it on your phone anymore. So very easy for you to hit a cast button. And when you click on that cast button, it's automatically put up onto the TV and you pick off where you left off without you even having to click any buttons on your TV remote. Like it's reached that stage where everything is interconnected. And it's not just TVs. You've suddenly got YouTube has got an app on a smartwatch. They have to support CarPlay. And then it gets even weirder form factors. Like you've got these like tablets that kind of sit in the kitchen. They're kind of tablets. They're kind of not tablets. The interactions are a little different. Fridges. For God's sake, who thought we should add Android to a flippin' fridge? Like, it's ridiculous. But it's just like you're getting these digital smart home experiences being added on everywhere. And a lot of apps will start supporting them, and your users will start expecting you to be also supporting them. And then suddenly you're in this sort of hell of supporting 7 different platforms. And then there's the more popular ones that are emerging. Everyone's seen this, right? So the Vision Pro changes UI quite significantly. So when you put on a Vision Pro, everything looks different compared to what you're used to on your phone or your laptop. You've got these translucent environments and UIs and little surfaces, and you got 3D objects. But then the crazier part is that when you're using your MacBook or your phone in the Vision Pro, it's all interconnected. So you can see your screen of your MacBook from your Vision Pro. Like it's all of these different interconnected, seamless handoffs between the Vision Pro and the Mac and the phone and so on and so forth. So you're getting all of these experiences becoming interconnected more and more. And it's not just Vision OS. There's Meta's Horizon OS as well. So that's one of the things that's happening. You're seeing all of these different form factors come through. And there is one more thing that's been popularized in the news lately. It is the shit show that is Gen AI. And this has already been mentioned in a talk before mine, which kind of makes me feel a bit more confident saying this now. When you look at Gen AI apps, they almost always seem to have the same interface. A bland chatbot. Like, I don't know about you folks, but whenever I go on a website and need customer support help and I see a chatbot there, I run away. I never want to use a chatbot willingly. And for some reason, we've decided that chatbots are the way to go forward. So will the next age of frontend be chatbots? I sure as hell hope not. And I don't think it's going in that direction. And this is basically going over Tejas' talk, so I'll just go through it very quickly. But if you look, there are some really good examples of how people are actually integrating AI. So this is the new Windows, and they're actually adding small AI features that are rather interesting in some ways, but some of them are smart. They're augmenting your experience rather than just throwing a chatbot in your face. It lets you add creativity and augments the experience of you creating paintings or writing text and so on and so forth without it being this big chatbot that you have, things like live captions. It's not that the AI is the experience, it's that it's augmenting your pre-existing experiences, all on the native layer. You see the same trend with the new Mac OS update. You can see that there is this AI that's integrated natively into the operating system, and all third-party apps can start using them from day one if you have a native app. If you want to shorten text that you've written inside of your app, it's already there in the AI. If you want to transcript audio that's coming in from voice calls and so on and so forth, it's already there. And you also get accessibility stuff. This is really important. If you have a native app on iOS or on Mac OS now, there's accessibility tools baked in because all of this is native code that the OS can understand, and it can liaise back with the AI that's there to help people that need that from an accessibility perspective. Like, these are all good movements and good uses of AI that I think are phenomenal. So if you look at all of these experiences that we've just talked about, and you put them together, the next era of front-end has seamless handoff between all your different devices that you use throughout the day. There's a lot more form factors of devices coming out. There's AR, VR, and there's AI. So we're going towards an era with increasing fragmentation and new form factors coming out. One where AI is going to be deeply integrated, but basically augmenting the UX as opposed to becoming the thing that people use. Where people have, a single user may have multiple devices that they switch on throughout the day, and where users expect universal seamless experiences. Universal seamless experiences, that's the key here. I think that's the common trend that you see, that those experiences are not limited to a single device, they're going across multiple devices that they use throughout the day. Ultimately, we're going into the universal first era. So then the question arises, well, what technology should we use for this universal first era? What's the best technology to create these universal experiences? Is it Flutter? Well, Flutter doesn't use native runtimes. It's very similar to how Java and Flash works. It's got a canvas, whether that's in Skia or Impeller. It doesn't support 3D and spatial computing, so AR and VR are just out of the picture. And it has really poor web support because it renders everything on a DOM. It renders everything on a canvas as opposed to the DOM. So definitely not Flutter. Let's burn it and burn it with fire. I have wanted to do that for a long time. Maybe it's Kotlin multi-platform and Compose multi-platform. The issue, again, lies with Google, thinking that they can do everything better by just popping it into a canvas. So they use canvas-based rendering for both web and iOS. So not native. Poor SDK compatibility. So if you ever try to use KMP with Swift, you'll know that sometimes it does really poor job, and you have to do a lot of manual work to make sure your libraries work. And again, poor web support. So not that either. Maybe we all just become native developers. But again, that's expensive. It's slow. People usually can't afford that anymore because it's costly and the economy is in shambles. And that seamless handoff actually becomes really difficult when you've got a bunch of native teams to coordinate, and we're adding more and more and more devices. So it's only going to get worse. So native is no longer an option. And so ultimately, we're really just left with one technology. I may be a little biased here. Whoever that one person is who's doing all of the, you're amazing. Love you. Okay. So React Native, we know, is a platform-agnostic API to define UI that maps to the native layers. And so you have truly native experiences. Yes, it started from mobile experiences, but you can now target desktop, you can target web, and you can even target TV, as you saw. I'm doing a recap of all of the talks at this point. Vision OS, native support for Vision OS. No other cross-platform technology has gotten this. Tools like Expo Router already have solved handoff between all of the different platforms because, again, you're dealing on the native layer, so you can have seamless handoff of the state of the user by just natively integrating it into the OS. It's all already there and baked in, and we've made all the right steps there. When it comes to AI, Copilot, which Microsoft released, is built in React Native. So there's a lot of React Native-based AI applications. And we can even go a step further, because if you've seen the recent talk that Evan Bacon did with a demo of RSCs, it actually works perfectly well for generative UI, as we saw with Tejas' talk today, because it knows how to render native layer components inside of an AI-based application. So you can basically render context menus and native alerts and timers and all of that and hook that into the native layer. Whereas if you look at the existing apps that are already there, like ChatGPT, Gemini, or even Claude, none of them have this functionality because it's just not something that's really possible and feasible and scalable with any other technology. And then, of course, when you look at AI, you've got to also address the elephant in the room, which is like we're going to all be using AI to code as well. And if you look at the top languages on GitHub in 2023, JavaScript and TypeScript are at the top of the list. Kotlin and Dart are very low. You don't see Swift or Objective-C anywhere. So there's far more training data on JavaScript, TypeScript, and React effectively to train LLMs on and effectively have better Gen AI to generate code for you. Do I need to say more? It's backed by big tech and it's being used on the App Store. So it's already a very stable technology. It's not going anywhere. And it ticks all of the boxes we've talked about. It handles seamless handoff. It works on smart devices. AR, VR is already being worked on and is pretty decently supported. I mean, there's still work, but it's as far ahead as any of these cross-platform technologies can be. And AI support is something that is only going to get better, and I think it's the technology to build AI-based applications with. So then have we hit the holy grail? And the pun is very much intended being inside of a church. Is write once, run anywhere finally a reality? There's still a little bit to go. We're very close, but there's a few things that we need to work on as an ecosystem and as a community to get there. So the first thing is React Native works incredibly well on iOS and Android, but the moment that you step out of those platforms, you're now in out-of-tree territory. And parity with the core React Native in that situation is not great. So big shout out to the Microsoft team who've been maintaining React Native Windows and React Native macOS is probably one of the best out-of-tree platforms in terms of maintenance. And even then, when you look here, they have over 160 open issues on places where there isn't API parity with the core of React Native. And this is one of the better ones. So it's a real challenge to keep up to par with core on React Native. Let's look at another platform, tvOS. tvOS has developed a whole bunch of different APIs that have not been standardized, are not on par with React Native Core, to handle things like remotes and focus management. You can use track focus, autofocus props. Then there's a whole bunch of components you can use. There's an imperative API that you can use that just fundamentally goes against anything that React stands for. Like, you can do that. There's now a TV focus guide. And so there's about 6 different ways to do the exact same thing when you're using TV navigation because there's been no standardization around this. And the kicker here is that none of this works on web-based TV operating systems. So you'd need another solution for any platform that isn't Android TV or tvOS. So that's the state of where we're looking at when we're at out of platform. And I have a hypothesis as to why this is. And if you open up the APIs for React Native Core, so this is from the reactnative.dev webpage, and you look at any of these components, let's say Pressable, and you scroll down, you'll find props that are a bit odd. Props like these two. Android_disable sound. Android_ripple. Okay, maybe it's a fluke, maybe it's just Pressable. Let's look at text. We have 2 different props that effectively are doing very, very similar things. Text break strategy, that only works on Android. Line break strategy iOS, only works on iOS. And the issue, I think, is that React Native is actually currently tightly coupled to iOS and Android. It makes them first-class citizens and inherits some of the mobile native APIs and basically creates the API design around them, which is not a scalable way to do this because React Native should be a platform-agnostic API to define UIs. It shouldn't be tied to any platform, mobile, web, or so on and so forth. So maybe it's time for a cleanup, perhaps Lean Core v2.0. Now, when we look at some other platforms like web, there is really good effort towards bringing the web APIs closer to native. And this is really important, and the Microsoft team has been working really hard on this. The key factor here is that web APIs are incredibly mature. There's a lot of React libraries that already support web APIs. So if you support web APIs in React Native, you can inherit a lot more from the web ecosystem and use it in native applications, which is honestly the direction that we should be going towards. So big kudos to them for doing this. And React Strict DOM as well is another element of making web support more first class. Right now, if anyone's used React Native Web in production, show of hands, has anyone used React Native Web on production apps? 1, 2, 3, handful of people basically. You'll know that there will be serious bundle size issues with React Native Web, and it'll slow down performance comparatively to not using React Native on web and just using bare React. And I think the key is that React Native Web has actually become a really bloated dependency that pulls in a lot of stuff that you oftentimes don't want. Like animated is a JavaScript-based animation runtime. You want to probably use CSS for that when you're dealing with the web. And so React Strict DOM is almost the right direction to go because it reduces the bundle size footprints, but it also uses the web where it makes sense to use it for the web. Again, looking a little bit into more detail on the website, CJS versus ESM, just a quick reminder for anyone who's not familiar. CJS imports and exports come from nodes. Back in the day, they look something like that. On the right-hand side, you've got ESM. One of the key benefits of using the import syntax from ESM is that you get access to things like tree shaking, which is really important when you're dealing with the web, and bundle size is incredibly important for you as a core web vital. Unfortunately, React Native, and this is a personal opinion, is far behind other frameworks in this JavaScript ecosystem in terms of adopting ESM and getting rid of CJS. And you see that when you're trying to use React Native on the web. So there's many libraries that are just CJS, like AWS SDK is one of them. It adds a whole bunch of bloat into your bundle, and a lot of that is not even shown here. They're unmapped. So it's all just a single CJS export. But then it's not just the CJS only libraries. There's ESM libraries that get referenced by CJS libraries, and then all of those libraries also get fully imported in, so you've lost all hope for tree shaking in the React Native ecosystem, which means your bundles are massive if you import the wrong library into the web bundle. And so Expo's been doing the work of God with this. I really like Expo Atlas because it basically tries to address this problem. React Native's never cared about bundle size because we've had Hermes, our startup times have been fine, it's never been a factor for us. This, I think, is a step in the right direction for this type of thing. And then on just third-party libraries quickly, if you look at something like Expo, it's probably one of the best set of libraries in terms of supporting web as well and supporting some out-of-tree platforms. But even then, it's incredibly inconsistent. It mainly supports iOS and Android, but some libraries will support web, some will support tvOS, some will support, other out-of-tree platforms, basically. So I think this goes back to that whole factor around React Native not having a complete API surface. If you look at Microsoft's RFC, they say that we have a wild west of community modules right now. Each of these have their own behaviors, and ultimately it means that it's the developer's responsibility to figure out what libraries to use. And when you're trying to create a universal app, what that means is you'll need one library for the web implementation, one library for iOS and Android, and then if you have any other out-of-tree platforms, you may need to find another library. It's not scalable because it's on the developer's responsibility to do that. Now, on the bright side, we have some really good UI libraries that we can use universally. So Tamagui, GlueStack, Native Wind, these are all amazing efforts to make it easier to share UI across native and web. And the handoff issue is being worked on because of the Expo folks and Expo Router, so all good. It wouldn't be a React Native talk without a final mention of the new architecture. It's coming soon. One of the things that the new architecture is promising, which will make it much easier to create universal first apps, is that you have turbo modules as a new concept, and you can use C++ code that is shared across all of these different platforms natively. And sometimes it'll be a little bit of C++ code, sometimes you'll have a bit more C++ code, or you may have mostly C++ code or even all C++ code. And when you have C++ code, all of your out-of-tree platforms can use the same native level code, and you don't have to duplicate iOS-specific, Android-specific, and so on and so forth in terms of the platforms that you have. So ultimately, what that means is that you can share a lot of code across different platforms, and library maintainers can have a lot more flexibility to adopt out-of-tree platforms. Okay, I'm out of time, and I've talked about a lot. A lot is changing in this ecosystem. If there's one thing I'd like for everyone to take away from this talk, and effectively from all of GeekConf, it's been this notion that React Native is not only a mobile platform. We need to shed this notion that it can only be used to create cross-platform mobile apps, because ultimately we're only hurting ourselves. There's so much more potential to this technology. React Native is a desktop framework. It's a web framework. You can use it for TV, AR, VR, and yes, you can also use it for mobile. Ultimately, React Native is a universal language for defining UIs. And if all of these different efforts come together and we put all of these as a forefront in our ecosystem, they're all individual puzzle pieces. And if the stars align perfectly and all of these puzzle pieces are completed and put together, React Native will power the next age of frontend, because it'll become the clear contender for building the experiences that we're all going to be expecting in the next 5 to 10 years. So it's really the front runner to solve all of these problems. And I really do think this will become a reality. And my personal belief is that the future of React Native and the brightest days of React Native's futures are ahead of it. So the future of React Native is incredibly bright. Thank you very much.